This is Ken Forrester, Executive Director at Momenta. Welcome to our Digital Thread podcast, produced by, for, and about digital industry leaders. In this series of conversations, we capture insights from the best and brightest minds in digital industry. They're executives, entrepreneurs, advisors, and other thought leaders. What they have in common is, like our team at Momenta, they are deep industry operators. We hope you find these podcasts informative, and as always, we welcome your comments and suggestions. Good day and welcome to episode 239 of our Momenta Industrial Impact Podcast. I'm pleased to introduce Ramakrishna Nanjundaiah, CEO and co-founder of Phantasma Labs, a company transforming production planning and manufacturing with its reinforcement learning AI technology. Phantasma is our newest investment from our Industrial Impact Fund. Rama is a leader in computational mechanics and AI-driven innovation with significant experience across the automotive, aerospace, and architectural industries. At MAN, Diesel, and Turbo, Rama developed the first AI-driven generative models for gas turbine blade profiles. At Rasch, he created one of the world's most extensive pedestrian simulations, modeling the movement of 2 million people in Mecca. His expertise extends to creating simulations for Airbus, improving aircraft thermal comfort, and evaluating megastructures in Qatar and Saudi Arabia. So Rama holds a master's degree from the Technical University of Munich. Rama, welcome to our Industrial Impact Podcast.
Great, Ken. Thank you for having me here for this podcast.
We're very proud to be an investor in you guys. What I appreciate about really your guys' DNA is the depth of understanding in large-scale reinforcement learning applications. And so I think you've got a good story to tell in terms of a origin story. But first, let's start with your personal origin story. So, we always like to ask, what would you consider to be your digital thread? In other words, the defining interests and experiences that brought you to this point.
Sure. I think I really like that question because it kind of underscores how I transitioned from a classical mechanical engineer to building AI and simulation-driven models for enterprises. So I would say my digital thread is in the domain of scientific computing, which kind of encapsulates both the classical computing paradigm and the new paradigms that we see with emerging AI technologies. And in fact, one could really make the case that new AI models are computational models of human brains in a certain way. So when I graduated from India with my degree in mechanical engineering, I thought I would be spending a large part of my life solving equations in mechanics and fluids. But that changed drastically when I did my master's in scientific computing at TU Munich, which I believe was the first defining point in transitioning into my digital thread, which is basically a scientific computing. And I really understood there how one could leverage modern computing paradigms to solve real-world problems, which was further reinforced by, let's say, a series of roles I had in this domain, and very exciting roles where I could really build some of the world's complex simulations and AI models to really build solutions that not only save cost, but also lives. So that, in a sense, became inherently my edge, so to speak, to build real-world applications based on scientific computing paradigms for solving real-world challenges.
As I said, quite an interesting origin story. That's the reason we like to ask this. So let's jump right into it. Kick things off. Briefly introduce Phantasma Labs and your vision behind founding the company. So what gap in the market were you looking to address?
Great. So we envisioned to build Phantasma Labs with the insight that there are several real-world use cases where one could leverage AI without the need for big data. And this is coming from my previous roles in the companies where I really used simulations instead of real-world data to train AI models. And when I looked at the market, it felt like there are a lot of use cases where you could create great AI solutions for enterprises that are traditional, that are classical, and that don't have big data. And we started out Phantasma Labs to take this technology that has been proven to enterprises that don't have data in essence. And to do this, we started leveraging reinforcement learning methodologies, right? And the key is that when we started our company, this idea was really contrarian because in 2017, 2018, let's say the hype of AI was still at its peak, especially with supervised learning-based approaches. And everybody thought if you want to build AI models, you need a lot of data. But we started out differently, where we said, look, you don't really need big data to train these models. And we pitched our idea initially to automotive clients who are building autonomous cars. And we showed that this approach works well, where you can train models and simulations and not just big data. And that helped a lot of enterprises to catch up with, other companies who had a lot of data. And with that success, we transitioned to the industrial market. The reason being that we found that this market is where we can create the biggest impact with our technology. And number two, it's a large market, but that's ripe for innovation because there's so many factories and companies that really are looking at benefiting from AI, but they don't have the data for that. So our vision for starting Phantasma Labs was to use combined technologies of simulations and AI to take AI methodologies to classical companies that don't have big data and don't have the competence to build these models.
So Phantasma Labs is revolutionizing production planning with AI-driven solutions. Can you briefly explain how reinforcement learning works with your platform and what makes it more efficient than traditional planning systems?
Right, so that's a very good question because we get asked this question a couple of times when we talk to our customers. So the reinforcement learning methodology that we use differs from, let's say, classical planning solutions in a couple of ways. First of all, it's the speed of execution, right? So our planning solution at the customer's end works way faster, typically 100 to 200 times faster compared to classical solutions. And the reason why this happens is because we take the burden of computation away from the customer and we do it on the training side, which means that our models are exposed to various different planning scenarios even before they have been deployed to the customer's end. And secondly, different to classical planning solutions that rely traditionally on operations research or heuristical approach, we don't have to compute the results for a new scenario of planning from scratch. So if you think about a factory, for instance, you have a plan, you're executing the plan within a factory, and something unexpected happens, right? So you have machines breaking down, you have staff not being there in the right time. And typically with the classical approach, if you want to regenerate a plan for such an application or a scenario, then you have to do the computation of all the plans from scratch because that's how the mathematical models work. But with reinforcement learning, we don't do that because the model has a very, very efficient way to move to the next optimal solution without disturbing other parts of the plan that are not needed to be touched because of this change. So in essence, our planning not only becomes faster, but it also becomes better because reinforcement learning approach are known to give the global optimal solutions compared to classical planning solutions. And that creates a very fairly effective planning results for optimizing manufacturing systems.
As I describe your company, I've taken to referring to you guys as AI planning and scheduling versus advanced planning and scheduling. Still, of course, the same APS TLA. And so it resonates with people pretty well. And certainly the results speak for themselves. So I know that many AI-driven platforms rely heavily on big data. Obviously, you guys have taken a different approach. Can you explain how your technology bypasses the need for the traditional, massive data sets and why this is a game changer, especially for small to medium enterprises or mid-sized manufacturers?
Right. So absolutely. So this has got to do with underlying technology, what we use, which is reinforcement learning. And the fact that we don't need big data comes from the environment side of the reinforcement learning approach. So if you think about a reinforcement learning approach, you have the environment where we stage different scenarios, and the agent learns from the impact of the scenarios, and it learns the best possible course of actions. And typically what we do is, on the environment side, we are able to generate millions of scenarios at scale. So if you want to get data of millions of scenarios from real world data collection from factories, this would take you pretty much between half a year to a number of years, depending on the complexity of scenarios and the size of the factory. But because we leverage modern computing paradigms, we have a unique scenario generation toolkit, as we call it internally, that generates various kind of scenarios, which kind of also simulate the emergent scenarios within factory that might come up, but the factory has not seen in the past. So this means that the factory doesn't have to wait for big data or collecting this data from real worlds to leverage AI technologies. And secondly, this also comes from the aspect that we are able to accurately model the processes within the environment to a very high degree. And typically, you cannot leverage reinforcement learning with simulations if you can't model the processes well as a simulation. And this really needs a lot of expertise and understanding of the domains. What I would like to highlight is that this is unlike training your models in synthetic data sets, right? So you have a different approach where you could have different scenarios, throw out the data, and train the models on that. But we have a different approach where the model learns pretty much in the simulation. And this is really a game changer for SMEs and mid-caps. First of all, because for them to get the data that you need to train such a model without environmental simulation, this would really mean that they have to invest millions upfront and also wait for 2 to 3 years to get enough data, which we shrink down to like less than 3 to 6 months, and also reduce the cost of data collection by up to like 80%. And further to that, we also leverage technologies like what we call as knowledge distillation, where we distill the learnings from a particular set of scenarios and apply these learnings to new scenarios that we get from new customers. And that makes it really, really effective in a sense that you learn, the model learns just like how you learn in a curriculum, which means that your model is getting not just incrementally smart, but exponentially smart with different scenarios being exposed. So the need for data is kind of negated by our technology that we can generate these scenarios on the modeling side of the environment, and also on the algorithmic side of the agent, that the agent doesn't have to learn from scratch every time because it's learning like in a curriculum manner.
I keep coming back to this idea of an origin story, and for you guys particularly very interesting. So, before founding Phantasma, as we mentioned, you had an impressive career working on large-scale simulations at SL Rasch and Man Diesel and Turbo. How did those experiences shape the development of Phantasma today?
I think there's a lot of similarities between simulations and AI. So it's just that they work in different directions. The simulations are basically systems where you give them a set of inputs, then you get an output for that. But a typical AI model, like the one that we build, it works the other way around. So you have a desired output, but you would like to determine the optimal set of inputs that lead to these outputs. So definitely working on these simulations helped us to understand where the strength of simulation lies and where the weaknesses of simulation models can be complemented with AI. And the unique experience of taking this kind of a new technology to real world projects, so specifically my work at MAN in 2012, we built the AI models even before the AI boom. And back then they were called just as meta models and not AI models. But we could already see the impact of such models on real world applications. So that really helped us to, number one, understand the kind of toolings, infrastructure, and technology we need to build enterprise-grade software with AI and simulations. And number two, to really believe in the impact of such technologies, right? Like I've seen that these technologies save lives. Prior to doing the mecha simulations in my previous job, there used to be a lot of stampedes and people were losing lives. And through simulations and AI, we literally could save lives. So currently, there are no more stampedes happening in Mecca, although there are 2 million pedestrians. They're moving at the same time. So that's the impact that we have seen and we have created. And we are trying to replicate the same Phantasma as well.
You guys have really gained a lot of initial traction in Germany, particularly. And now, obviously, with the recent investment by us and some of the other co-investors, you're looking to expand, especially into the US. What challenges do you foresee in scaling into such a new market at this point?
Absolutely. So we are really excited to have Momenta and other investors on board because that catalyzes our expansion to these markets. We see 4 key challenges in expanding to the US market particular. So first of all, we are talking about a very traditional market, and which means that we need to have specifically local sales force potentially to address the larger needs of this market because the US is a huge market in itself. And secondly, we see that a large part of the market is fragmented in terms of digital maturity. So even if you look at a particular segment like a mid-cap or a SME segment, your USP has to be broad enough to address this. And this needs a clear understanding of what are the needs that would fulfill 80% of this market. And that's quite hard to determine because it changes between the markets and the vertical you're addressing. And thirdly, what we have seen is that the market tends to be very local and geographically dominant. What I mean to say is that if you look at Detroit, it's very strong on automotive, as the Seattle area is more strong on aerospace. And their needs are different. And the ecosystems, the toolings that they use, the integrators they use, they are different. And for us to deliver the best of our product, we need to leverage and get in touch with the right people in this ecosystem because we strongly believe in an integrated approach. And all this means that we need to find a landing vertical in this market and the region where we can land first and expand to different verticals and expand the regional coverage in this vertical as well. So I think we will have to overcome these four hurdles or let's say challenges before we can expand to the other markets, specifically the US market.
Yeah, and because we are backed by Rockwell Automation as our anchor LP, obviously there's always that possibility and opportunity to partner in a lot of that. I think that, the farther you look for large MES or manufacturing execution system providers, the more you find potentially an interesting, OEM growth path to a lot of these, and especially reaching down to the small to medium enterprises where I think there's so much opportunity in this space. And thus, part of the strategy was, of course, we all operate in the manufacturing sector, and we know it has been fairly slow to embrace digital transformation, especially some AI these days. What do you see as the most significant barriers holding the industry back, and how do you think Phantasma Labs is going to break through some of those obstacles?
Right. So we have spoken to a number of different customers across different markets, geographies in the last couple of months and year. But we have seen some consistency in terms of the obstacles in approaching customers in this market. So first of all, it's something got to do with misconceptions around AI, because a lot of people in the industry think AI would come and take their jobs or the data will be misused. And also, we have seen that the management keeps shifting focus with regard to what kind of AI technology they would like to use. So prior to ChatGPT and LLMs, everybody wanted to do AI for predictive maintenance and forecasting of orders and pricing. But the moment you had the ChatGPT movement, we can see that the management is really asking about, can you guys also build ChatGPT for us internally? And we always had to explain to them this is not possible. So there's a lot of gap in terms of expectations of AI and what AI can actually do for them. And secondly, I think a lot of customers are worried about potential significant upfront costs with AI solutions and unclear return of investments. And I think a lot of this has got to do with unmet promises by AI technologies in the past, because people expected AI to deliver more much earlier, but some things take time to build and to deliver results. And we have seen that a lot of AI projects in the past at companies have been, say, POC projects, which is now shifting. So all in all, we believe that this misconception around AI has been quite a crucial factor. And secondly, we have seen there's a lot of political inertia in the industries, majorly set by legacy tools. So typically, factories have some existing tools, and they're really reluctant to replace them or also open up this tool to expanding the capabilities, right? And that's partly got to do with reluctance to changing user behavior within factories. They wouldn't like to get a new tool or train their person on a new tool, but rather just live with what they have. And also, there's this political inertia because they want to have humans in the center of everything. And that is still the case with AI. But due to the misconception so which they believe that AI will take over jobs, they believe they don't want to push the solution too much because it could take away humans being at the center of things. And thirdly, what we see is that there's a difference between perceived value and real value of AI solutions. And we have seen this going both ways. So sometimes we had customers who perceived much bigger value from AI technologies, while the value that that AI could generate is probably lesser. And also some customers really don't value the full benefit that they're getting from this technology. So we have a different approach to overcome these barriers, right? So first of all, on the value side, we help our customers understand the before and after scenario of using AI solutions like ours. So we help them really understand, how better the plants get truly by using the solutions. And this can be taken down to KPIs of saving costs, saving time. And also, we intend to reduce the upfront cost and deliver ROI in 6 months. So we hope that all of this would reduce the barriers for us. But still, I think there's quite some work to do to address these, not just at the level of Phantasma Labs, but also at the general market conditions.
So one of the things we really liked about you guys was your focus on the small to medium enterprises. It is a common theme across some of our other portfolio companies as well. So I guess one, how are you targeting these companies? And two, how is that working out in practice?
Right. So we target, as you mentioned, specifically the SMEs and the mid caps, which happen to be like 80% of the market that we're operating in. And in order to make it impactful and easy for our customers to leverage this technology, we have a very unique USP for these customers. So first of all, we reduce the amount of upfront cost and onboarding time. So which means that we take away the burden of longer development cycles for these projects for our customers, but rather ship our product to them in less than 4 weeks. And this makes it really easy, and our customers love this because they can see the impact of the technology and models in 4 weeks, through which they can make a clear decision as to how much of a value they could get when they use this on a long-term basis. So this speed of adoption, which is unique to our technology and our execution, has been very well received in the market. And secondly, it really meets the current situation of this underserved market, right? So we see a lot of customers in this domain that are really keen on using AI solutions, but they don't have the data, they don't have the means to do that. And we go to these markets and we tell them, look, you don't have to change the way you are, but we could take from this situation where you exist and we could take you to the next level of optimal production systems with our AI-based planning solutions. And that is something which the customers like, because typically in these markets, our customers believe that they need a lot of preparation to use our kind of solution. But with our unique advantage of technology not needing big data and to easily integrate within the existing tooling, we are able to serve these underserved markets in a short time frame and have them hooked on for a longer period of usage of a product as well.
So given your extensive background in computational mechanics and AI, I'm curious, what technology advancements do you foresee having the most impact on manufacturing in the next 5 to 10 years?
Right. So I'm always quite excited by innovation computing. And I personally believe that one of the biggest shifts will be the speed and the cost at which we could train and ship models to our customers. And I sometimes controversially also believe that at some point, the Moore's law of computing will be universally broken, which means that you would see way faster computing technologies through which you can train models much, much quicker. And this is quite important from a practical perspective because this determines how fast and how cheaply we can ship these models to our customers. And secondly, I see that the industries will shift AI development more towards algorithmic development than big data alone. So classically, if you think about customers in this domain, they always thought they need a lot of data, and that's how they were trying to drive innovation by collecting a lot of data and training models of that. But as our understanding of the domains improve, I think the shift will be more towards the algorithmic development of AI, which means codifying the human knowledge, the human intelligence in AI, than just trying to get more data and training AI models in a black box manner. And thirdly, I believe that more and more AI technologies will become part of a human feedback loop, which means that you don't see these models just understanding and learning offline, but they would work in conjunction with humans, where humans will give a feedback to the models, whether these models are giving the right results or not. So I believe these will definitely be something that we achieve in the next 5 to 10 years time frame. Particularly the speed of computing will be something which we will see in a much, much shorter time frame.
So as we conclude, I'm curious how you stay ahead as a leader in such rapidly evolving space. What books, podcasts, thought leaders, etc., do you refer to advance really your own knowledge and keep it up to date?
So I tend to be a voracious reader. So I do read a lot of books in this domain, and particularly books written by well-known authors like Ken Sanderson, with his book on designing industrial autonomous systems. That's something which I'm currently reading. So I do read a lot of books in this domain, and I do recommend Ken Sanderson's book to leaders in this domain who are driving AI revolution. And there are a couple of great podcasts where you get the thoughts of more industry leaders in this domain. One of the podcasts I like is the Industry AI podcast, which is sponsored also by Siemens. And that tend to have a very futuristic view of AI can shape up the next innovation cycle in the manufacturing sectors. And what also adds value is being in touch with specific working groups, right? And we are part of working groups that are designing the next potential systems for industrial domain, including data spaces, including standardization of models. So these are the aspects I am involved in to really keep up with the latest advancements in AI and maintaining my edge.
Excellent. So, Rama, thank you again for sharing this time and these insights with us today. It's been a really good conversation.
Great, Ken. Thank you so much for having me here. And also, I appreciate the support of Momenta in our journey. And I'm super excited to be part of this journey because we are in exciting times of driving AI revolution in the industrial space.
Absolutely. And we're very proud to have you guys in our industrial impact portfolio as well. So this has been Rama Nanjundaiah, founder and CEO of Phantasma Labs. Thank you for listening, and please join us for the next episode of our Industrial Impact Podcast. We wish you an impactful day. You've been listening to the Momenta Digital Thread podcast series. We hope you've enjoyed the discussion, and as always, we welcome your comments and suggestions. Please check our website at momenta.one for archive versions of podcasts, as well as resources to help with your digital industry journey. Thank you for listening.